day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the next generation Accuplacer, Quantitative Reasoning, Algebra, and Statistics practice questions. Let's take a look at question number 1. It reads, which of the following expressions is 5 times as much as the sum of R and S? We have 4 options here. So what we're going to do is we're going to convert these symbolic expressions into word format and see which one matches this expression provided. Okay, so how would you express 5 times r plus s using words or a verbal expression? 5 times r plus s following the order of operations require that we multiply first before we add. So you remember the order of operations. Please excuse my dear Aunt Sally. Simplify the parenthesis first, exponents, multiply and divide from left to right, and then add and subtract from left to right. Okay? So how would you express this using words? So 5 times r plus s using verbal expression is simply the sum of 5 times r and s, indicating the correct order of operations. Okay, so let's write this down. Option A is the sum. You state the last expression first. Okay, the sum of 5 times r and s. Okay, now let's take a look at option B. We have 5 plus r plus s. They're exactly the same operation, namely the sum. It doesn't really matter how the order in which you add, you will still get the same answer. So if you want to write this expression in verbal format is going to be the sum of 5 r and s. Okay? Now let's take a look at option C. We have product and sum again. Referring back to our order of operations, we are going to multiply first before we add. Okay? So how do we express that in verbal form? In this format right here, we're going to be finding the sum of r and 5 times s. So this will be the sum of r and 5 times s. Or you can say, let's write it as s times 5, just to preserve the order there, even though it makes no difference. And s times 5, since we know that multiplication commutes. And then the last one, we have r plus s grouped together in parentheses times 5. Now, had it been we didn't have the parentheses provided, multiplication will be carried out before the addition. Okay, but now that we have parentheses, you're at the highest point in the order of operations. So in this situation, you're looking at the sum of r and s times 5. Okay, so you can write this as the sum of r and s times 5. Times 5. Okay, so we can also rewrite this in a different order, since multiplication commutes. If we have a times b, for example, it's the same thing as b times a. So we can rewrite this as 5 times the sum of r and s. this still follows the order of operations, which involves multiplying R and S and then multiplying it by 5. Okay? Now, if you take a look at the 4 options we came up with, the one that involves taking 5 and then multiplying it by the sum of R and S, the correct option is clearly option D, because we have 5 times the sum of R and S, which is the same thing as the sum of R and S multiplied by 5, as option D provides. Okay, so answer to question 1 is option letter B. Now let's take a look at question 2. It reads, what is the solution to the equation 1/2 x plus 3 over 2 times the quantity x plus 1 minus 1/4 equals 5? So this equation is an annoyance. It doesn't look really good. Why? Because of the fractional components of the equation. So here's a tip for solving equations that look annoying as this. The tip is, when solving equations involving fractions, what do you want to do? You want to make your life easier. You want to make it possible for you to solve the problem with as less difficulty as possible. So when solving equations involving fractions, eliminate the denominators first. Okay? So if we can eliminate the denominators, we are creating a situation where it's easier for us to solve the equation. Okay? Now, let's take a look at this. We have 1/2 x plus 3 over 2 times x plus 1 minus 1/4 equals 5. In this particular problem, we have 3 denominators, 2, 2, and 4. Okay, the goal is to eliminate those denominators in one step. How do we accomplish that? If you want to eliminate denominators from an equation, all you simply do is you find the LCD of the denominators. So the question now is, what is the LCD of 2 and 4? The LCD of 2 and 4, the smallest number that evenly goes into these two, is 4. Alright, team? So what we're going to do is we're going to multiply this entire equation by 4, and that will eliminate the denominator component of this equation. Okay, so we are multiplying every single term of the equation by 4. If we multiply the equation by 4, let me show you the steps so no one gets confused. You're distributing 4 to every single component of this equation. So 4 goes to the 1/2. That gives you 4 over 2. X plus 4 times 3 gives you 12 over 2. So 3/2 times x plus 1 is considered to be one term. So you only multiply the coefficient by 4. Minus 4 times 1/4, 4 over 4 equals 20. Now what happens when you multiply an equation involving fractions with the LCD? The equation should be reducible into a form where there are no denominators. Check this out. 4 over 2 is 2. We have 2x plus 12 over 2 is 6 times the quantity x plus 1 minus 4 over 4 is 1 equals 20. Now compare this equation with the original equation. Which one would you rather deal with? It's easy to see that the equation without the fractions is easier on the eyes and is also easier to solve. Okay? So now that we've rewritten the problem in a simpler format, let's go ahead and solve it. So let's distribute the 6 first. So the 6 gets distributed to the x and 1. That results in 2x plus 6x plus 6 minus 1 equals 20. We can combine like terms on the left side of the equation. We can combine 2x and 2x if we combine those two. Sorry, 2x and 6x, that yields 8x. And then if we combine positive 6 and negative 1, that gives us plus 5 equals 20. Now to finish this off, we will simply subtract 5 from both sides of the equation. And then that gives us 8x equals 15. Final step, divide both sides by 8. And we have our final answer, x equals 15 over 8. The answer to question number 2 is option letter C. Okay? Now let's take a look at question number 3. It reads, what is the number of grams in 500 kilograms? And we're provided with a conversion factor here. 1 kilogram equals 1,000 grams. So one tip concerning conversion of units is as follows. Tip on conversion of units. What's the tip? When converting units, you want to align the units based on how identical they are with one another. Okay? So the tip is you want to align identical units on the same side of the equation. Okay, if you do that, then you'll be setting yourself up to be successful when you're solving the problem with whatever algebraic approach that you're using. Okay, so align identical units on the same side of the equation. What am I talking about? Well, let's take a look at this example. We have two units. We have grams and kilograms. Okay, grams and then kilograms that we're supposed to find. So let's say we don't know what this is. It says, what is the number of grams in kilograms? So let's call that x grams in 500 kilograms. All right? So let's write down a declarative statement concerning our unknown. Let's say, so let x be the number of grams. Let x be the number of grams in 500 kilograms. Okay? So with this, we can set up an equation. So if you have, so whenever you want to set up an equation involving an unknown, and it also involves conversion, it's beneficial to start from the unknown variable. Okay, so we're looking for x. So x grams is equal to 500 kilograms. That's the first statement. This is a question. All right. We also know that 1 kilogram is equal to 1,000 grams. Now, I indicated to you earlier in our tip that you want to align identical units on the same side. Grams are going to be on the left side. Kilograms will be on the right side. Okay? So 1,000 grams is equal to 1 kilogram. Okay, so have it aligned like this. Now what we have is we can convert these two statements into a proportion. Okay, so you can say x kilograms per 1,000 grams is equal to 500 kilograms per 1 kilogram. Now with this setup, we can simply multiply both sides by 1,000 grams, and that will give us our answer. Okay, so considering the fact that this setup is now a proportion, which is a statement that two fractions are identical, we can just multiply the left side by 1,000 grams and the right side by 1,000 grams. What happens on the left side is the grams cancel out, the 1,000 is gone, and we have what we're looking for isolated, which is excellent. X grams is equal to, now if you simplify this right here, you can cancel out the kilograms. 500 times 1,000 is 500,000 grams. Okay, so what does this tell us? It tells us that there are 5,000 grams in 500 kilograms. Okay, there are 5,000 500,000 grams in 500 kilograms. Answer to question number 3 is option letter D. Now let's take a look at question 4. It reads, Robert sells 4 different flavors of jam at an annual farmer's market. The graph above shows the number of jars of each type of jam he sold at the market during the first 2 years. Question, which flavor of jam had the greatest increase in number of jars sold from year 1 to year 2? Okay, so the formula that we're going to be using for the problem solving process is as follows. So your formula is says amount of increase is going to be year 2 amount minus year 1 amount, right? So if we just subtract the final from the initial, then that will give us the increase. That's how you calculate increase. Alright, so what we're going to do is we're going to compute the increase from year 1 to year 2 for the different flavors of jam. Alrighty, let's start with blueberry. So blueberry is going to be in black. So for blueberry, we have year 2 minus year 1. So blueberry increase is going to be year 2 amount is the one in black as indicated here. It's not clear what that is. So what we will do is we'll extend the bar graph for blueberry to the x-axis to the y-axis. So that's 15, 16. It looks like it's 17. Wait, 15, 16, 17. Roughly, let's say it's like 18. So 15, 16. Yeah, it looks like 18. If you do it with your pencil or your graphing tool, it's easier to see exactly what it is. So it's like around 18. That's fine. It's not going to be a problem. So year 2 is 18, roughly 18. And then we're going to be subtracting year 1, which is clearly 10. 18 minus 10 is 8. So this is the increase in year 1 from year 1 to year 2 for blueberry. Now we're going to take a look at grape. Carry out the same calculations. I'll do this in red. So for grape, we need to find the amount increase. Final minus initial. The final is 30, and the initial is 25. 30 minus 25, we get 5. It cannot be option B because it's less than the amount increase in option A. Let's go ahead and take a look at peach. Option C. So for peach, we have to extend the lines to the y-axis to know exactly what the year 1 and year 2 amounts are. So let's extend this. I'll make my line a little bit skinny so I can get the exact reading here. Let's use that. Okay, so for this is not working. For peach, year 1 is extended. Looks like we're looking at 5, 6, 7, 8. Year 2 extended. We're looking at 10, 11, 12. Alright, so 8 minus 12, 8 minus 12, or 12 minus 8, sorry, we need to do year 2, which is 12 minus year 1, which is 8, and that's 4. This is smaller than option A, so we eliminate that. So that's the amount increased. Now the last one is strawberry. Do we have to do any work for strawberry? If you take a look at strawberry, what do you notice? Year 2 is smaller than year 1. There was a decrease in this flavor, so we can just eliminate that. Okay, but let me just show you the computations that leads to my conclusion here. So for strawberry, we don't have an increase, we have a decrease. So the increase here, what kind of answer do you think we are going to get? Year 2 is 20, as you can clearly see. So 20 minus year 1. Year 1 is what? Year 1 is 35. So 20 minus 35. That gives us the amount increase. So 20 minus 35 is negative 15. Okay? So this is a decrease. A decrease is equivalent to a negative increase, which is smaller than option A, which is positive. So our answer is option A, because that had the biggest amount of increase in the number of flavors sold from year 1 to year 2. Now let's take a look at option number 5. It says, in the xy plane, a line crosses the y-axis at the point 0, 3 and passes through the point 4, 5. Which of the following is an equation of the line? Okay, so if we want to write down an equation of the line, we have the options here. We are going to use the formula known as the slope-intercept form. Slope-intercept form. Now, why are we using the slope-intercept formula? There's another formula that can be used, which is the point-slope formula. But in this particular case, we're given a point on the y-axis. This point has a special significance, and that point is known as the y-intercept. Okay? The slope-intercept formula is y equals mx plus b. Alrighty, b is the y-intercept. So if you're given the y-intercept, all you have to do is find the slope and you're ready to generate the equation. Okay? So for this formula, there is also another component, which is the slope component. M is the rise, y2 minus y1, over the run, x2 minus x1. Okay? So what we're going to do in this problem is identify the y-intercept first, and then we find the slope, put them all together into this equation, and that will be our equation of the line. Okay, so we have our points. Let's write down our points. 0, 3, which is equivalent to x1, y1. We have 4, 5, which is x2, y2. So our y-intercept b is equal to 3, because that's where the graph cuts the line crosses the y-axis, or where you have a 0 coordinate value. So we have b down. Now we need to find m. How do we find m? We're going to use the formula that we wrote here for the slope. So the formula for m is y2 minus y1 divided by x2 minus x1. Okay, so we have y2, 5 minus y1, which is 3, divided by x2, 4 minus x1, which is 0. 5 minus 3 is 2. 2 divided by 4 minus 0 is 4. Now, what is 2 divided by 4? don't get tempted to call this 2. That's a common mistake a lot of students make. So you want to reduce it completely, okay? So if we want to reduce this, we will be dividing by the greatest common factor, the GCF, the greatest common factor of 2 and 4, the biggest number that can go into these two is the GCF. So the GCF here is 2. So we divide the top and the bottom by 2, and that results in the fraction 2 divided by 2 is 1, 4 divided by 2 is 2. So that's your slope. Your slope is 1/2 and not 2. Okay? All right, now we have our y-intercept and our slope. The formula that's going to help us put it all together is y equals mx plus b. So the equation of the line is y equals m, which is 1/2, x plus b plus 3. So our final answer is option letter A. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Accuplacer exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial or any math questions on the Accuplacer, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to this review series. And also do visit our website at mathgotserved.com for our formula collection and also access to our interactive practice test. Thanks again for watching and have a wonderful day. Goodbye.